My name is Rainer Blatt and I'm a professor here at the University of Innsbruck. Here is the Institute of Experimental Physics, where we are doing research on quantum optics and quantum information. We have several research projects, but the mainstream project that we are dealing with is best described with the buzzword quantum computer, which is about quantum information science. We want to use single atoms and their interaction with photons to process information in a quantum way, and finally to produce with that quantum machines, quantum sensors and quantum computers. There are many future challenges. I mean, the holy grail of all of this is finally getting to, for example, a full functional quantum computer. The full functional quantum computer is never going to replace a classical computer, but it's going to enhance it. And the idea will be that we finally can process information faster than we could do it with classical computers in order to get better results for material science, chemistry, for information science, for everything that we need. And for this, the key problem is going to be, at this time, the implementation of quantum error correction. That is, in my point of view, one of the most important things that we need to do, because then building a real quantum machine, a reliable quantum processor, that's going to be easier if we have implemented that. I originally started out in metrology. That's, for instance, frequency standards and measuring precisely the time and frequency, for example. And then this gradually changed, of course, with quantum methods, and over the years, of course, we developed in collaboration with friends and theorists then new ways of doing this in quantum physics, as, for example, the notion of quantum information processing, which arose essentially from research that we did in quantum optics. The Austrian Science Fund essentially pays for all the personnel that actually does it, PhD students and postdocs, and of course pays for some of the special equipment that we need in order to carry out that research. In that respect, the Austrian Science Fund has an enormous role and is very important. And at this time, unfortunately, the financing of the Austrian Science Fund is too scarce. The government needs to really support the FWF in a much better way than it does these days. In fact, we have recommended that the resources the FWF gets are doubled in the future, which would really make a major difference, because at this time there are very many, even excellent applications that cannot be financed because of the lack of resources. So it really is the concept of the SFP focus to investigate the behavior of the microscopic world to sort of a mesoscopic world on the other hand. And the future, of course, is going to be to understand this to even more macroscopic ensembles and to understand the macroscopic world in terms of quantum laws that usually govern only the micro world. Of course, research as such is absolutely important for any society, because that's how we build our future. Innovation rests on research.